Okay, well, here's the next part of chapter 12. If you remember what we were doing the other day, right, we were going through and we were talking about mole ratios. So if you notice that the balanced equation that I have here at the bottom of the page is the balanced equation we were using in an example. And the coefficients that are in front of each of these compounds, each of the reactants and products, are the number of moles required to do that reaction, right? So the equation that you see at the bottom there says 1 N2, right? There's a 1 there even though it doesn't show. So 1 mole of N2 plus 3 moles of H2 yield 2 moles of NH3. So we decided we could then write mole ratios from those coefficients. And so up at the top of this slide here, you see if I wanted to know what was the mole ratio between nitrogen and ammonia, right? 1 mole of nitrogen and 2 moles of ammonia is what shows in that balanced equation. So I just wrote them one over the other, right? Because a conversion factor is what we're going to make out of these, and we need them to be written like fractions. Okay, so those are our mole ratios. Once you have mole ratios, once you have a balanced equation and you know what the ratio is between one of the compounds and another compound, we can now change that reaction however we want to. For instance, and we saw this on Monday, right? So we were going through and we were saying, well, if this is our balanced equation, right, this is a 1, okay, so I have 1 N2, I have 3 H2, I have 2 NH3. Well, what if I didn't want to make 2 moles of NH3? It's kind of like a recipe, right? You look at the recipe and it says, oh, it makes 2 dozen cookies. Well, what if I don't want 2 dozen cookies? What if I want 4 dozen cookies? Well, that's fine. If I want to make 4 moles of NH3 instead of 2 moles, that's all right, I can do that. But I have to keep the ratios the same. So if this were 1 N2 to 2 NH3, well, now I'm going to have to, if I double NH3, I'm going to have to double the N2 also, which means I would also have to double the H2. And so those are the new numbers that I get, right? 2, 6, and 4. It's still a 1, 3, 2 ratio. All I'm doing is I'm just taking those numbers, and if I change one, I have to change them all by the same amount. Now, this is a really simple example, but they're not always going to be this simple. So again, I want you guys to learn how to write out some work that will help you do any kind of problem, no matter what numbers I throw at you with that balanced equation. Okay? So let's go ahead and we're going to take this same balanced equation. Let me get rid of all this. So this same balanced equation that you see here, right, we're going to go through and use that to solve a couple of problems. All right? So just remember that. You might want to write that one down on your paper so that you remember what it looks like. All right, we're going to use that now to solve some problems. So first problem, right? Let's say that we have 2.5 moles of N2. How many moles of NH3 could we produce? So we're going to set these up kind of like we've been setting up all of our problems since we started it back in chapter 10. We always start with our given. So our problem says 2.5 moles of N2. So that's what we know, that's our given. So we're going to write that first. We always write our given first. So 2.5 moles of N2. Then we're going to multiply by a conversion factor because I want to convert this. I don't want moles of N2, I want moles of NH3. That's what it asks for. So whatever I don't want goes on the bottom. So I don't want moles of N2 anymore. So I'm going to put those units on the bottom. Whatever I'm looking for goes on the top. So that means moles of NH3 is going to go on the top. Okay. Now, what numbers do I put with these units? Well, that goes back to our balanced equation. in our balanced equation, it had a 1 next to N2, and it had a 2 next to NH3. So this is telling me, if I solve this, this is telling me that if I take 2.5 times 2, I will get my answer, which of course would be 5, right? And I have to put my units with it. So my units would be right here, because that's the part that didn't cancel. That's what the part I'm looking for. So moles of NH3. And then I circle my final answer, because I always try to make sure that I can tell where the final answer was. So again, start with your given, and then you multiply by our mole ratio, whatever mole ratio we're looking for. In this case, we needed moles of N2 to go to moles of NH3. And the numbers for that always come from the balanced equation. If you don't have a balanced equation, you can't do these problems. So you have to have a balanced equation. Most of the time, it will be provided to you. But of course, we've already learned how to balance equations in here. So even if it wasn't given to you, you could balance it yourself and then go forward with the problem. All right, let's clean this up and show the nice clean one. There you go. Now, let's go and try another one. This time, I want you to try it. Okay, so again, pause this on your paper. Go ahead and write this out. Solve it just like we solved the one above. Make sure that your units are canceling. Make sure you solve for your final answer. And then come back to this and see how you did. Okay, here we go. This is what it should look like. Right? So your given was 0.56 moles of NH3. So that's what you should have started with. You then needed to take moles of NH3 and you needed to change it to moles of H2. That's what it asked in the problem. So I put moles of NH3 on the bottom. Why did I put it on the bottom? Because that's what I started with. I started with moles of NH3. I better put moles of NH3 on the bottom so it cancels. And then what I'm looking for goes on the top. So moles of H2 goes on the top. And then I used my mole ratio from my balanced equation. Remember that balanced equation I told you to write down from the last slide? We're still using that. So there was a 2 in front of the NH3 in that equation. And there was a 3 in front of the H2 in that equation. So I put a 3 next to the moles of H2 on the top. I put a 2 next to the moles of NH3 on the bottom. And so according to this, there's 0.56 moles of NH3. So there's 0.56 times 3, because the 3 is on the top, I multiply, divided by 2, because the 2 is on the bottom, I have to divide by it. So 0.56 times 3 divided by 2 gives you 0.84. Now I know I have to make sure that my number of significant figures is the same. So I had 2 significant figures to start with, right? I had 0.56, that's 2 significant figures. So my answer had to have 2, which is 0.84, so that works out. And then once again, don't forget, you need to circle your final answer. Okay. So these are what we would call mole-to-mole problems, because they're allowing us to change moles of one substance in a chemical reaction to moles of another substance in the same chemical reaction. Okay? So mole-to-mole problem, all it involves, the only thing we have to worry about is the balanced equation. If we have a balanced equation, then we have all the numbers we need. We don't need a periodic table. We don't need anything else to do this kind of problem. It's the simplest of stoichiometry kind of problems. You know, I know you know that it doesn't stop there, okay? Because since we cannot measure moles directly in real life, we can only work with them on paper. That means that if we were actually wanting to do any of these reactions in real life, we would have to convert them to some other unit that would be useful to us. Grams, liters, something that we can actually measure. So that means that these simple problems like this, which were good to start with, are not the only kind of problems you have to be able to solve. Right? We have to be able to work with grams. We have to be able to work with liters. All right? So Sometimes it's easier to work with grams or liters, so we're going to learn how to do a conversion problem in which you're not only going to be converting moles, but you're going to be converting grams, you're going to be converting liters, maybe even atoms or molecules, because we've learned all those conversion factors back in chapter 10. So let me give you an idea of how this is going to work. This is going to be a problem that's going to involve 3 steps, not just one like we just did here. So for example, let's say we wanted to do what I would call a mass-to-mass problem. So a mass-to-mass problem means that the given is going to be in grams of one substance in a chemical reaction. And then your final answer is going to be grams of a different substance in that same chemical reaction. So you're going from grams of one substance to grams of another. That requires 3 steps. The first step, change the grams that you were given of the first substance, change that into moles. So all right, we're going to convert grams into moles. We've learned how to do that before. I'll remind you here in just a minute when we do a sample problem. We're then going to take the moles of that first substance and we're going to convert it to moles of the second substance. We're going to use our mole ratios like we learned just how to do a moment ago. All right. And then finally, we're going to take the moles of that second substance now, and we're going to convert it into grams of that substance. And again, we know how to do moles to grams. Right? So this is the 3-step process that we're going to learn how to do here. And we'll do an example problem so you kind of follow along with how this works. Oops, there we go. We're going to go back and use the same balance equation that we used before. It just makes it easy. I know you're like, what, can't we use something different? We could, but this is a nice simple one to use, and really it doesn't get any more complicated if you have a bigger balanced chemical equation. The key is the numbers that are out in front. That's the key. So if you've got a number here and a number here and a number here, those are the numbers that we really care about because those are our mole ratio numbers. That's the numbers that we're going to use for this step right here. This part, mass to moles or moles to mass, involves the periodic table, right? Because that's where you find molar masses. Those are the numbers off the periodic table you're going to need. So again, if you don't have a periodic table sitting in front of you, make sure you do. Make sure you've got a calculator. Hopefully you've already had that out because you've been doing some problems already. All right, so let's try to do this problem here. All right, so if you've got 6 grams of N2, how many grams of NH3 can you produce? Now remember, our balance equation, all those numbers mean in our balance equation is moles. They don't mean grams. So the only way that we know anything about grams is we're going to have to do some conversions on it. All right, so let's set this up according to the steps from above. It says first, take your given. So as usual, always write out your given. Leave yourself some space here, right? Because this is going to be a 3-step problem. We're going to need a lot of space. Now, I think it's always helpful that if you're going to start with your given over here on the left, that over here at the right side of the page, that you write down what units are you looking for. So if this was my given here, then right here is what I'm going for. So I'm going for grams of NH3. Okay? So grams of N2 to grams of NH3 is what I'm trying to do. And I need to fill in the steps in between. So first conversion factor. Remember, a conversion factor always looks like this. So let's see, on the bottom, we're going to put the units that we just started with. They started us off with grams of N2, therefore grams of N2 has to go on the bottom. There is no reason why ever you miss this part, right? Because all you're doing is copying. If the units at the beginning are grams of N2, then grams of N2 has to go on the bottom, okay? Has to be that way. Now, what are we going to change that into? Well, according to our first step up here at the top, the first step says moles of A gets changed to or mass of A gets changed to moles of A. So grams of N2 gets changed into moles of N2. Okay. Now, I'm not going to put any numbers with this yet. In fact, I would recommend that you don't even bother. You got to get your units right before you can do anything else. So, next, let's do the second step. The second step up here says that I'm going to change moles of A, and A in this case is N2, right? So we're changing moles of N2 into moles of what we're looking for, which is NH3. So I'm going to go from moles of N2 to moles of NH3. Right? Again, I'm not going to worry about the numbers here. I can go back and do those in a minute. All right. And then finally, the last step here, the last step from step 3 says change moles of the second substance, which is NH3 in this case, to mass, which is grams. So my last step, I'm changing moles of NH3 to grams of NH3. Okay, now follow along with me because I want you to make sure that you understand that this is the way it's supposed to look every time you do a problem like this. So you have grams of N2, and then grams of N2 are on the bottom here. So therefore, those units are going to cancel. Then you went to moles of N2, and you put moles of N2 on the bottom over here. Therefore, moles of N2 and moles of N2 are now canceled. Then we went to moles of NH3, and then we put moles of NH3 on the bottom. So moles of NH3 and moles of NH3 canceled. And finally, you had grams of NH3, and your final answer is in grams of NH3. Those have to match. They don't cancel, right? Because this is an equal sign here, but they have to match. All right, now let's go back and fill in numbers, okay? So let's go back to the grams and moles part. Remember I said before, to figure out how many grams are in a mole of something, you're going to have to look on the periodic table. So if you look at the periodic table for N, right, N nitrogen, nitrogen weighs around 14, right? Like 14.01 or something like that. So that means N2 doesn't weigh 14, it weighs 28. Right? So this will be like 28.02. I think that's what it turns out to be. Something close to that. And that's in 1 mole, right? In 1 mole of N2. Next, we were changing moles to moles. This is a mole-to-mole ratio, right? This is what we learned comes from the balanced equation. So now we're going to go to our balanced equation above. The N2 number here is 1. So I'm going to put a 1 down here. And then the NH3 number was a 2. So I'm going to put a 2 here. And then finally, the last step says grams of NH3 on the top to moles of NH3 on the bottom. So I'm grams to moles. That's periodic table numbers again. So NH3, I have to add up N and 3 H's off the periodic table. So again, N weighs what? 14.01. And then H3, well, each H is about 1 gram, so that's about 3 grams. So 3 and 14 makes about 17, right? So this is like 17, I think it's like 17.03. Again, the decimal can be a little bit different depending on what periodic table you're using, so that's fine. But I would try to go out as many decimal places as you can based on the periodic table that you're using. This is always how many grams are in a mole, okay? All right, so 6 grams is what we started with. Then we have 28.02 on the bottom, so that means I divide by that. And then I multiply by 2 on the top, and then I multiply by 17.03 on the top. So go through 6 divided by 28.02, then multiply that answer by 2, then multiply that answer by 17.03, and you'll finally get your final answer, okay? Again, let me put up the nice version. Here we go. Here's what it should look like, okay? So you got 6 grams at the beginning, 28.02 on the bottom, 2 on the top, 17.03 on the top, gives you a final answer of 7.3, which is grams of NH3. That's our 3-step process. Every mass-to-mass problem, every problem where they start you with grams and want you to end with grams of a different substance is always going to look just like this. The difference is going to be what numbers are you going to use off the periodic table, because the substances might be different, and the mole ratio might be different because you'll have a different balanced equation possibly. Now, here is the only difference between this and any other kind of stoichiometry problem that you might want to solve. You don't always have to go from grams to grams, right? Remember, we learned how to convert moles to liters or moles to atoms or molecules, right? We didn't have to do just grams. So that means that we could do this kind of problem, this 3-step problem, but we could use other units instead of just grams, and we could do it the same way. So let me give you an alternate version of this. Let's say that we had 6 grams of N2, okay, just like the problem said originally. But then they wanted to know how many liters of NH3 could we produce. Well, we can set this whole thing up very similarly. I have to change grams to moles for N2, then I have to change moles of N2 to moles of NH3, because I'm still going to NH3. That didn't change. The only difference will be at the very end of this, right? I'm not talking about changing it to grams of NH3. I need liters of NH3, right? My final answer is going to be in liters of NH3. So what would you use as the number? You wouldn't use 17.03. That's the grams off the periodic table. What number goes with liters? Do you remember that number? You remember the 22.4 number? That's how many liters are in a mole of a gas. Assuming these were all gases, okay, at STP, then 22.4 liters is how many liters of gas there are in a mole. So notice this problem would be very similar. It would be the same 3 steps, except that I'm not trying to go to grams at the end. I'm trying to go to liters, because that's what the problem asked. What if the problem didn't start me with 6 grams of N2, right? What if it started me off with, I don't know, 1.2 times 10 to the 24th molecules of N2, right? What if that's what it started me off with, and then wanted me to go to liters? Again, how would the problem look different? Well, you'd start with a different given. You'd start with 1.2 times 10 to the 24th molecules of N2. Oof. And then you would still have to change the molecules to moles. So you wouldn't have grams here at the bottom. You would have molecules of N2. How many molecules are in a mole? Well, we learned. It's that magic Avogadro's number, 6.02 times 10 to the 23rd. Right? So molecules to moles. This step, you notice this step has not changed at any point during any of these versions of this problem. A mole-to-mole ratio is used in every stoichiometry problem, no matter what. That's why it's so important. That's why we've learned so much about moles, because it allows us to go between all of these different units. You want to go molecules to liters? Fine. You want to go grams to molecules? Great. Right? You can do any of these as long as you have the mole ratio in the middle. Okay. So that mole ratio is really important, right? And it shows up in every one of these. So the steps that we have here at the top here, okay? change the given, and this part right here could be liters, right? Could be molecules or atoms or some kind of particle. Does not have to be mass. And then this part right here, again, at the end, doesn't have to be mass. It doesn't have to be grams. It could be liters, could be molecules or atoms or some kind of particle. It's the same 3 steps. The only thing that changes is what unit is your given in and what unit do they want your end answer to be. That's it. This is still moles, this is still moles, this is still moles, this is still moles. Doesn't change. Okay? So let's try a different balanced equation. Finally, we get to see a different balanced equation. It's still a really simple one, right? But you have a different balanced equation to work with. And this time, let's do one of those kinds of problems that I just talked about. So if you have 2 liters of NO, how many molecules of NO2 can you produce? So notice this one is starting us off with liters of NO and then wants us to end with molecules of NO2. So this is one I want you, just like we just talked about, I want you to try it out. Make sure that you're really doing this. Make sure you're not just waiting for me to put the answer up, because then you're not really learning anything. You got to try it out. Even if you're a little uncertain. I know it's not easy when you're doing these, but you have to try to do it because that's the only way you're going to get better at it. So I do want you to pause this, even if you have to go back to the one we just did and kind of follow that. That's fine. That's good. But you need to try this one out, set it up, see if you can solve for the answer, and then come back and I'll show you what the answer is, okay? All right, here's what the answer is going to look like. So let's break this down. You've got the beginning here, which is 2 liters of NO. That's our given, right? That's what was given at the beginning of the problem. That's what we always write down at the beginning. Then, like I always do, I always write down, what do I want to go to? What's the end unit that I'm looking for? So it has for how many molecules of NO2 can you produce? So I put molecules of NO2 at the bottom, or at the end, I mean. So I started with liters of NO. I'm trying to get the molecules of NO2. I know this is going to be 3 steps. I know it's going to be 3 steps. The first step is change the unit you were given into moles. Second step, change the moles of the first substance to moles of the second substance using a mole ratio. Third step, change the moles of that new substance into whatever unit they're asking for at the end, which in this case is molecules. So where did the 22.4 come from? Remember, how many liters are there in a mole? 22.4. Where did the 6.02 times 10 to the 23rd come from? Remember, anytime you're asked for atoms or molecules in a mole, that's the number, 6.02 times 10 to the 23rd. Where did the 2 and the 2 come from here in the middle? That came from my balanced equation. There was a 2 in front of the NO, so that's 2 moles of NO. And there was a 2 in front of the NO2, so that's 2 moles of NO2. So, and then this number and this number here that go with the conversion factor of something to moles, those are always 1s. Always. So you notice this setup here, this problem, looks almost exactly like the one we just did. It's 3 steps. It has a mole ratio in the middle, right? It's got conversion at the beginning that changes whatever units we started with into moles, and then it ends with moles to whatever units you're looking for. This is the way that all of these problems go. Okay? All of these kinds of problems always involve changing something to moles to begin with, then changing the moles to moles of something else, and then moles back into whatever units you're looking for. Okay? So when you're looking at a problem, look at what units you're starting with, what units you're ending with. If they are not moles, then that's your first step, right? So this was liters, I have to change liters to moles. If this were grams to begin with, I'd have to change grams to moles. If these were molecules to begin with, I'd have to change molecules into moles. My first step is always to change it to moles. My second step always is mole-to-mole ratio. And my third step is always moles then into whatever they're looking for, okay? All right, work on your homework problems. Email me if you've got any issues or any questions, and I'll help you out. There's no problem with that, okay? Work on that stuff. Make sure you can do it, and I'll talk to you later.